All right, so in the last video, we saw that we talked about the things to watch for, right? So that we can easily do these ones. So we know that we are using what we are seeing for this question, although sometimes we can use calculations. We'll work with calculations in the next questions, but for now, we are using what we are seeing. So now they're saying, at what domain points, that's the first question, at what domain points does each function appear to be I differentiable? So we are doing question 4. Okay, question 4. Right. Now I'm going to work with part A. So it's going to be AI, then AII, whatever. So at what domain point does this A appear to be differentiable? When does it appear to be differentiable? Look at this. It's going to be differentiable in every point. Okay, it's going to be differentiable. Remember, we want the domain points. So from -2 to 3, the whole thing is going to be differentiable. Why? There is no cusp. It is continuous. Number one, it's continuous. And 2, it has no point or cusp. So it's going to be differentiable everywhere. So here you can see that you can say it is differentiable from -2 to 3. Okay. Why did you say it is from -2 to 3? Because you can say no sharp corners or cusps. Therefore the whole domain, the whole domain is differentiable. Okay, is differentiable. So you can say it is continuous and has no sharp corners. Okay, you can put that to say it function. Let me put that. Sorry for having to edit. Function is continuous and has no sharp corners or cusps. Therefore, the whole domain is differentiable. Okay. Now we can go to do part 2, where continuous but not differentiable. Do we have any part where it is continuous but not differentiable? No. Okay. No such point. Where it is continuous but not differentiable, there's no such point. Okay. Now, that is for the first graph. It is differentiable everywhere. So there's no point where it is continuous but it's not differentiable. Now, 3 is neither continuous nor differentiable. Here there is again no such point. So here you can say no such point because it is smooth. Okay, it is smooth throughout. We say that it has no cusp. That's the same thing. Okay, it is smooth throughout because they want reasons. That's what they say. Give reasons. So that is why it is smooth throughout. You can say that it has no cusps, no sharp corners or cusps. That's what I mean by smooth. So no sharp corners or cusps. Now we are doing part 3, which is neither continuous nor differentiable. You can say that no such point. Okay, where it is neither continuous nor differentiable. Why do you say it is continuous? You say it is continuous. It is continuous. Function is continuous. We can say that because there are no jumps or asymptotes or vertical asymptotes. So function is continuous. Function is continuous. You can say since there are no holes or jumps or vertical asymptotes. Okay, holes, jumps, or vertical asymptotes. Okay, you understand? And then you can now say function is also differentiable. It's also differentiable everywhere throughout the domain. Okay, throughout the domain D. Okay, why? As there is no sharp point, or cusp. Here it is. We are done. That's just what we look at. And this is the part A. Now we're going to do part B, where we answer all these questions for this second graph. Okay? Goodbye for now. See you in the next one.